with the three Venn diagrams, nothing's changing. So we're going to read this question. It says, in the diagram below, let P represent the number of people who have pets, let C represent the number of people who have cholesterol issues, and let D represent the number of people who can't decide on what they want for dinner. So they did some survey. They asked a group of people. It doesn't say how many people, so we don't know the number in the universal set right away. These three questions, and you said yes or no to each one of them. And then they got sorted into a Venn diagram like this. And we have to answer these questions based on that Venn diagram. So the first question says, how many people only have pets? The word only is important. That means they have pets and they don't have cholesterol issues and they can't decide where to eat on dinner. So how many people only have pets in this thing? It'd be 3. So it'd be that number right there, because that's the only thing that doesn't intersect with the other two. It's in the circle P, but it's not in any of the other circles. So the answer to this one would be. Now number 2 is a different question, even though it sounds very similar. This one says, how many people have pets? So if you're trying to figure out how many people have pets, you're trying to figure out how many people are in the entire circle of pets. So you're going to have to take every number in that green circle and add it up. So you're going to have 3 plus 1 plus 6 plus 1, and you'll have 11 people who have pets.
Can you only have one twice?
The reason there's one twice is because there's a 1 here and a 1 here. It just means one person has a pet and cholesterol issues, and then one person has a pet and can't decide what's for dinner. But it's 2 different people. Yeah. All right, question 3. How many people have cholesterol issues and can't decide where to eat? So you're trying to figure out, by looking at your Venn diagram, how many people have cholesterol issues? Well, anyone in this blue circle has cholesterol issues. And you're trying to figure out who can't figure what they want for dinner. So you're looking for anyone that's in this circle as well. And because you're looking for and, you're looking for where they would intersect each other. So you're looking for this region right here. How many people have cholesterol issues and can't figure what they want for dinner? 8. It'd be 6 plus 8 people have a cholesterol issue and can't decide what to eat. Question 4. How many people have pets or, the word always works, cholesterol issues? So you're looking for the number of people who have pets. That's anything in this green circle. You can shade the whole thing in. My shading just doesn't look very good on this board. So you're looking for anyone in that red circle or anyone who has a cholesterol issue. So you're going to do the entire green circle. And again, you could shade the entire thing if you want. That's how I would recommend you do it on your paper. If you had multiples, it's kind of hard when you do it all in one. So you're looking for the number of people who have pets or who have cholesterol issues. So that means you're looking for any number that's circled in one of these bubbles. So you need to add up number 3 to number 1, 6, 1, 16, and 2. It's a little crazy over there. So, yeah, question. Oh, what's the answer? It's 81. So you take all those numbers. I'm just going to write them down so you can visualize it. It's 68 plus 2 plus 1 plus 6 plus 1 plus 3. And units has got 81. So 81 people have that situation, pets or cholesterol issues. Five. What does the number 2 that's outside of the circle mean? So the number 2 that's outside of the circle is this number 2 right there. I highlighted in blue. What does that number 2 mean? Robert? Yeah, they don't have any of the three, and Brandon is listing them. They don't have any pets, they don't have cholesterol issue, and they don't, or they do know where they want to go for dinner. So 2 people on that entire survey said no to all 3 of these things. That's what that represents. I'm not sure. You write that here. It's the number of people with none of the 3. I'm going to call them things. None of the 3 things. You could write out pets, dinner, cholesterol. Just don't have much room. Sounds like those people are lucky. No pets, they have good cholesterol, and they know where they want to eat. I'd say the best group is right here.
Yeah, I guess it's 5.
Yeah, I want a pet, and I don't want cholesterol issues, but I want to know what I want to eat. All right, the last question. What does the number 2 inside the circles mean? So there's the number 2 right here that's inside the circles. How would you describe those 2 people? I wish I'm wrong.
People with cholesterol issues and people who don't really have.
Yep. So it's people who have cholesterol issues and people who don't know what they want to eat, but they don't have pets. So there's going to be that third condition in there. If it was just cholesterol issues and they can't decide what to eat, then you would have to include this group as well, right? But because we're just talking about the number 2, that's people who have cholesterol issues, can't figure out what they want to eat, but they don't have a pet. Yeah. Yeah. So you can write that out however you want. I'm going to say 2 people have C and D, but not. Again, remember, this was one of those things that I said if you had a Venn diagram, it just makes reading surveys way quicker. You can imagine having all these people's surveys listed out, and then trying to figure out, okay, how many people can't have or have a pet and have cholesterol issues, but don't have problems deciding where to eat dinner. That's hard. You're going to read through every survey to figure it out. You just look at a Venn diagram and say, oh, there's only one person who has a pet, has a cholesterol issue, but knows where they want it. So they're not that deep. It just makes reading things fast, very efficient. All right, we're going to shade in a couple. We did 2 slides of this. Last time I think we did like 3 or 4, so we got a lot of practice yesterday with those. This question says, represented in words and then shade the region. So this is A and C. In words, we would say all things in A and B. Again, my suggestion to figure it out was to shade things in. So if I want to be in A, I'm going to shade all the things in A. If I want to be in B, I want to shade all the things in B. And because the word separating them is and, then I'm looking for where they intersect each other. So where's my green shading intersect my blue shading? Right here. That's the only place they intersect. So I'll shade that. That's the section on this Venn diagram I'd be looking for. Try B on your own. See if you can shade it. See if you can remember what it's saying to you. thing, if you were to read it verbally, would be all things in A or B. So I'm going to shade in all the things in A, which I did in the blue. And I'm going to shade all the things in green, or sorry, in B, which is in green. And because it says or, that means I want anything that's been shaded for A or B. So I want all of this, including where they intersect with each other. So that's a really big area I'd be looking at to figure out my data. Those are all the things that are in A or in B. All right, C. We're going to read that one together. This is all things in A and not in B. So some keywords. And came from there. Not came from that apostrophe up there. So if you're trying to figure out and, then you're going to circle all the things in one group, all the things in the other, and then you're going to figure out where they intersect each other. So go ahead and give that a shot and shade it out. Okay, so when we shaded that thing, I shaded blue are all the things in A, and then my green is all things that are not in B, which is a lot of things, right? It's anything outside of that B circle. And because the word is and, you're looking for where the two shades would overlap each other. So in our case, the two shades overlap each other here. Right? It's not quite all of A, but it definitely has a lot of A. That's all things in A and not in B. Alright, those were still like pretty basic. These are the ones that get a little more complicated. Because now you got three things going on, you got a lot of knots going on, which makes things challenging. So, I always said try to resolve what's in the brackets first. We're not going to worry about the wording on this, like writing it out, but we're just going to worry about shading it. So, this thing in the bracket says all things in A and not in B. So if I'm shading that out, all things in A, all things not in B, would be that. And if I'm looking for the and, where do these two things overlap each other? I should cover this here. Where's the overlap on this if we're shading this in? It's like this little crescent spot here, right? We can draw a blue line around it. So this thing right here. That's where they overlap each other. I drew a blue circle around where they overlap each other. That would be just the portion that's in the brackets. So that would be our answer to the first part of the question, would be the blue stuff. So I have that blue portion as being what's inside the brackets. Put it in now, so we know where it is. Now you want to try to do the second part of the question. The second part of the question is and not in C. So you want to take this blue portion and try to intersect it with what's not in C. So the portions that are not in C would be this green that I'm drawing in here. And because the word is and, you're now trying to figure out where the blue intersects the green. It's hard to tell with this smartboard shaking, It's easier if you're trying to do like a page and you have multiple colors. So I'm saying it might be wise to get some pencil crayons to do some quick shading on these tests and quizzes that you're going to get. So what things, where does the green intersect the blue? Yeah, it's most of A. It's like this like awkward little shape. So it looks like this. It intersects here and like that. Anything outside that red little bubble that I just created isn't intersecting. You'll see there's a whole lot of green around the outside, because not C is a lot of things. And then there's a little bit of blue over here that's not been touched by any green, so we don't include that as well. That's a difficult example. That's probably the hardest one. It gets a little tricky.
So, is the answer everything that's shaded in, or just the red?
The answer would be just the red. Just the red portion was the brackets and not C.
So on a test, it's shaded in red.
Yeah, you could shade in just the red. Some of you guys, as you... Is that your spoon? Yeah. Okay, that's it.
Just throw it in.
I was going to throw it away. Like on a test, and as you guys get reading these, you'll probably be able to do them almost without shading. You'll be able to really easily tell like where that is. Be like, okay, and not see it's this. But that's just going to come to practice. All right, we try B. I'll give you that one a shot on your own. Actually, now we'll do B out together. So, do the brackets first. Try to figure out where A or B would be. So if you were shading this, you'd shade all the things in A, all the things in B, and then it would be anything that's shaded is what you're considering. So in our case, A would be all of that, B would be all of that, and because it's or, then anything that's shaded is included. So it would be the red, the green, all of it together. That would be your shaded region for the brackets. So the brackets are where they intersect each other, where they don't intersect each other, for the bracket. So now that you've figured out where the brackets are on your Venn diagram, you now want to figure out and not C. So and means anything that's intersecting, not C. So if I was to shade in not C would be out here, all the way around the outside edge. It would also be anything inside here that doesn't actually touch C. So basically you're taking that crazy blue shade that we had, and you're trying to figure out where the black would be touching it. The black would be touching it all these colors so you can see. Alright. So that should be your answer. That's all considering A and in B and not in C. That's a lot like our example. You had a pet or you couldn't figure out what you wanted for dinner, but you didn't have cholesterol issues. Right? That would be a good example of what that would sound like in words. It's A or B, not C. Okay, see if you can figure out the right area it's asking for in C. So give that one a shot. I'll shade in where the right answer is, and you see if you can work your way towards that proper answer. more minutes. Okay, so if you're shading that thing in, you're looking for anything that's in B or C. So if you were shading, you should have had all here. Anything in blue should have been shaded for the brackets. And then you want to figure out what of that intersected with A. And that's why I shaded in just that red portion. That's the only spot that would have been in the blue and was part of A. So a good example of that would be, if we were talking about that other example, would be people who have cholesterol issues and they can't figure out what they want for dinner, and they have a pet. Okay, so that intersects everyone else. Okay, the last example is building a Venn diagram. And this is usually the harder part, right? Usually people are pretty good at reading Venn diagrams. It's building them that's hard. And when it gets to the 3 Venn diagrams, it gets even more challenging. My suggestion is always try to build these things from the inside out. But sometimes you don't have enough information to do that. So we're just going to do our best here to put all of this together where it needs to go. Out of 185 students surveyed, that's going to be important. 185 students, that means that's our universal set, that there's 185 things in there. The following information was gathered about students who drink root beer, Coke, and orange pop. We're going to go bullet by bullet. If we know where it goes in the Venn diagram, then we're going to put it in there. If we don't know where it goes in the Venn diagram, then we're going to leave it alone. So the first part says 25 drink all 3. We do know where that would go in the Venn diagram. That means they drink root beer, and they drink Coke, and they drink orange pop. That intersection spot would be right in the dead center, which is good, because you usually want to build from the inside. The next bullet says 52 drink root beer and Coke. That's useful information, but we don't know where that goes, because 52 drinks root beer and Coke covers whatever number is going to go here, plus whatever number goes there, plus whatever number goes there. I'm lying to you. I said or. It says and. Yeah, so it doesn't cover that. It covers whatever number goes. Yeah. I'm like, I just said the and word, and I just gave you or. It goes there, where I left the line, or there. Yeah, sure. Positive this time. I double check my work. So 52 drink root beer and Coke. So we need to figure out what that blank line would be. How could we do that? 52 minus 25 would tell you how many people were missing that drink Coke and root beer. So 27 people drink just Coke and root beer. 25 drink Coke and root beer and orange pop. But they would still count as people who drink Coke and root beer. Yeah, they're on the edge, man. They take everything. 43 people drink Coke and orange. So now we can do the same thing. We know that those 43 people should be right here plus right here. Did I get that right? Okay, orange? Got it. How can we figure out that number? Well, we're going to go 43 total minus the 25 that we know do all 3. Is it 18? It's 18. So you know 18 people have to go in this slot to make up the total number of 43 that do both. The last one, see if you figure where that one goes on your own. So give it a shot. It's pretty similar to the other 2 that we just did. So 57 drink root beer and orange. So if you want to figure out how many people were missing from that intersection, you would go 57 that do everything, and you would subtract the 25 that do all 3. It's gone forever. I always throw it around. That's how I keep myself busy. That's
Sounds like it's students.
yeah, this beats like doing it.
Think fast.
All right,
Bunch of ramps, you can have the ball.
92 people drink root beer. So that encompasses the whole circle for root beer. So you need to think there should be 92 people in this entire circle. So to figure out that missing number in here of the people who just drink root beer, you got to go 92 and then subtract all those other numbers. So subtract 27, subtract 25, subtract 32, subtract people. And that'll tell you how many people should be in that root beer category all by themselves. That's all they drink. You want to throw that in your calculator?
8.
8? So if you punch all that in your calculator, it leaves only 8 people who are only consuming just root beer. So 92 minus 27 minus 25 minus 32, we should subtract 18. 18 people weren't part of root beer. I read that wrong. So 92 minus 27 minus 25 minus 32. I hope that you caught that mistake when I was writing out numbers.
On the back foot of my head.
Yeah, see. You would have had it. Is it still 8? Yeah, it is still 8. Okay, good. Now you want to figure out the 115 people that drink Coke. Well, that means if you add up all the people who drink Coke, it should equal 115. So to figure out who drinks just Coke, you go 115 minus the other 3 numbers. This time I do 118 because they drink Coke. So 115 minus 27 minus 25 minus 18. 45. So 45 people just drink Coke. They don't like root beer. They don't like 25. There you go. Yeah. So how would you do the last one?
I did 18 plus 25 plus 32.
Yep. Yep. And that would tell you. So if you took all the people who drink orange pop, which was 100 people, and then subtracted out the 3 categories that also drink orange, you should get so she makes a good observation here. If you add up all these numbers that we just calculated, it equals 180, not 185. Which means we're missing 5 people. Where would they be, Roman?
On the outside, there are 5 people.
That's your 5 people who don't drink any of the 3 pods.
They're the ones drinking the good stuff like Pepsi.
Yeah, they got Pepsi, Diet Pepsi, maybe cherry Pepsi, vanilla Pepsi, Kool-Aid, maybe just water. Kool-Aid. Kool-Aid. Yeah. Okay.